So today we have, again, we'll continue from last time. We were talking about classification. And again, this is like the first half of classification. So the first lecture, and we were talking about max margin classifier. And I think you will also, you will have like, you have a programming assignment on classification, and that's using nearest neighbor, which is kind of a simplistic format. Uh, so let's continue on that. So today we'll have this new segment, which is support vector machine. And again, this is going to be like on top of what we discussed last time on max margin classifier. Okay, so let's try to understand like why we need support vector machines and why maximum margin classifier was not sufficient. So let's try to understand this scenario. In this case, we have two different classes. We have blue and we have purple. All right, and again, this is projected on 2D space. And of course, we can generalize this to a multidimensional space as well. But in this particular scenario, if I have to build like a classifier, or let's say like linear classifier for sake, then it doesn't matter like what kind of boundary I draw. I will never be able to separate these two classes. Okay, so this is kind of a special case where your training samples are actually not separable. And the reason is, if you look at like these purple dots over here, this one and this one, so they're kind of in middle of these blue dots. And same is the case with like, you can say like the blue dot over here, it's kind of very close to the blue dots. So no matter what kind of boundary you draw, what kind of straight line you draw, you will always have error in your training sample. All right. So then how we can handle that? So one easy solution is we kind of relax the condition that your classifier should be perfect on the training data. So we relax that condition and we allow some kind of errors.